Hello and welcome to the Fleming's left-hand rule revision video from scienceworksheets.co.uk. Please like, subscribe and comment to support the channel. Fleming's left-hand rule is used to determine the direction of the force acting on a conductor when it carries an electric current and is placed into a magnetic field. You will often use Fleming's left-hand rule when working with electric motor questions or motor effect questions. Fleming's left-hand rule relates three quantities: the magnetic field direction, which is represented by your first finger, the current direction, represented by your second finger, and the direction of force or movement, represented by your thumb. We're going to use this as an example. In this case, the magnetic field is going from the North Pole to the South Pole, so from left to right. So therefore your first finger, which represents the magnetic field, should point towards the right-hand wall. Now, the current is going downwards. That's represented by that green wire. So your second finger will point down towards the floor. And that means your thumb should be pointing towards you, so the wire will move out of the screen towards you. In example 2, the magnetic field is still going from north to south in the left to right direction. So your first finger will point towards the right. However, the current has now changed direction. The current is flowing along the wire away from you. So therefore, your second finger will point towards the wall that's in front of you. And as a result, your thumb should now be pointing downwards towards the floor. So the wire will move down towards the floor. With an electric motor, it's slightly more tricky, because when the current flows through the green coil, on both sides of the coil, the current is in opposite directions. So that means that both sides of the coil experience a force in opposite directions, causing the coil to rotate. However, let's look at one side of the coil at a time. In the case of the left-hand side of the coil, the magnetic field is going from left to right. So your first finger should point to the right. The current is coming towards you. So your second finger should point towards you, and therefore your thumb will point upwards. So the force is on the upward direction. When we look at the right hand side of the coil, the magnetic field is still from left to right. So your first finger still points towards the right hand side, but your second finger will now point towards the wall in front of you because the current is going away from you. And this means your thumb is now pointing down towards the floor. So therefore the coil on the right hand side will move downwards. Thank you for watching. See our revision notes, practice questions, link is in the description.